I'm not sponsoring this uh, today's Zoom session with a fractal next Monday. I honestly I apologize for starting so late. Okay, all right. Today, lines and solving equations may be word problems. Although if there's not enough people, then I'll have to wait. Okay, so a line given 2 points in the plane, x1 by y1, x2 by y2. What is the slope of the line? What's the measure of the steepness? It equals the rise over the run. It's the change in y's divided by the change in x's. Uh, so if the slope is 0, it's flat. It's a horizontal line. If its slope is infinite, if it's vertical, going lower left to upper right at 45 degrees, a slope of +1. Going upper left to lower right at a slope at 45 degrees is a -1 slope. Rise over run. Y2 minus y1 is the change in the y values divided by x2 minus x1, that's the change in the x values. You could also write it the other way around. Y1 minus y2 over x1 minus x2. And you get the same slope. Slope from here to here is a slope from here to here. The direction is not relevant. Now there's a formula for given a slope, given a line that goes through h by k, the slope equal to s, then y minus k over x minus h equals s. They usually use m for slope for reasons that are a complete mystery to me. So I don't know how. 1, 3. Okay. So the equation is y minus k over x minus h equals s. I will repair this lack here. Transpose the x minus h, get y minus k equals s times x minus h. And then transposing the k, y equals s times x minus h plus k. That's the equation of the line through h by k with slope equal to s. Usually, the way the book puts it is y minus y naught equals m times x minus x naught. I don't like that formulation, partly because x naught and y naught look too much like new other variables. I have no idea why they use the letter m for slope. Measure, perhaps, with some Latin word. I have no idea. Anyhow, I find this a useful formula. Now, if the point is a y-intercept, so it's going through 0 by b with slope s, then we use this formula here with a 0 for h and a b for k because it goes through 0 by b. Y equals s times x minus 0 plus b. This simplifies to y equals sx plus b, the slope-intercept formula. Very simple formula, and it is easily remembered by the name, slope and intercept. Now, if the slope is 0, then this term goes away and y equals a constant. Vertical lines, the slope has to be infinite, and this formula breaks down, and we just say that x equals a constant h. Now, so this slope-intercept form works for all but vertical lines. There's a formula which works for all lines, vertical or not. Ax plus by plus c equals 0. That's the general formula for a line. If it has intercepts at x and y axis, then the x-axis is at negative c over a by 0. The y-intercept is at 0 by negative c over b. If lines are parallel, then the slopes are equal. If the lines are perpendicular, then the product of the slopes equals -1. Or in other words, each slope is -1 divided by the other. A proof goes like this. The book doesn't really give a proof, so I'll give one here. Let's imagine these two perpendicular lines. Shift them to going through 0 by 0. You can do that because parallel lines have the same slope. Here's 0 by 0, move over 1 to 1 by 0, go up s1 to 1 by s1. It's because this has slope s1. Turn the whole thing 90 degrees. This 1 by 0 goes to 0 by 1. This s1 becomes a minus s1 because it's pointing to the left. And so this point here is at negative s1 by 0. Now this line has slope s2. It goes to minus s1 by 1 through 0 by 0. And if you use a slope formula, it quickly gets you the s2 equals -1 over s1, which implies the rest. So here are some examples. Find the equation of a line with slope 3 and y-intercept equal to -2. That's y equals 3x minus 2. Okay. Find the equation of a line through 2 by 1 and 1 by 6. Okay, so these are 2 points. Each one of these we could use as the h by k, but we need the slope. Well, the slope is a change in the y values, 1 minus 6, over change in the x values, 2 minus 1. Negative 5 over 1 is negative 5. So a slope of negative 5. And let's say it goes through 2 by 1. Then we have y equals negative 5 slope times x minus h 2 plus k equals 1. And after a very little bit of algebra, that becomes y equals 5x plus 11. Now I chose the point 2 by 1, but I could have used 1 by 6, and it also would work. So there's two ways to the same solution. So I'm a little bit skeptical when the book asks for the proof. There's generally an infinite number or unlimited number of proofs for any mathematical proposition. Here's one. Find the equation of a line through 1 by 2 and perpendicular to the line y equals 3x minus 5. Now, all right, this line has slope of 3. So the perpendicular slope is negative 1 over 3 because perpendicular lines have negative reciprocal slope. So there's a slope of negative 1/3. It goes through 1 by 2. So y equals minus 1/3, that's the slope, times x minus this one, all that plus 2, this 2. After some light algebra, y equals minus 1/3 x plus 7/3. Here, asked to find the equation of the line through 1 by negative 6 and parallel to the line x plus 2y equals 6. Now, okay, for this one, first we'll need to find its slope-intercept form to find its slope. Y equals 2x plus x plus 2y equals 6, then 2y equals negative x plus 6, and dividing by 2, y equals minus a half x plus 3. So the slope of the second line is negative a half. And if you want parallel, this slope here also has to have a slope of negative a half. And it's through 1 by negative 6. So y equals negative a half, that's the slope, times x minus this one, plus this negative 6. And this, after some light algebra, is y equals minus a half x minus 11 halves. Now here we have 3 points, 1 by 2, 4 by 8, and 5 by 11. Are they collinear? Are they on the same line? Well, what we'll do is we'll find the slope between these 2 points and the slope between these 2 points. If they're equal, they're collinear. If not, then not. Here between 1 by 2 and 4 by 8, the slope is 2 minus 8 over 1 minus 4. It comes out to 2. Between here and here, the slope is 8 minus 11 over 4 minus 5, which comes out to positive 3. Not the same, therefore these are not collinear. Are these collinear? 1 by 2, 4 by 8, and 5 by 10. Well, this one is slope 2 minus 8 over 1 minus 4, which works out to 2. This slope is 8 minus 10 over 4 minus 5, also works out to 2. So these are equal slopes, and therefore these 3 points are on the same line. Now here, 101 is a applied problem. Driving 480 miles costs $380. Driving 800 miles costs 460 miles. Let's see the cost of driving d miles, I assume in dollars and miles. C equals what d plus what? We're assuming a linear function. And if d is 1,500 miles, what will be the cost? So what's the formula and what is it for 1,500 miles? Okay, the slope is the dollars per mile. So 380 minus 460, that's in miles, over 480 minus 800, that's dollars per mile. It works out to $0.25 per mile. Just a second. So slope is 1/4. Through, let's try 480 by 300. So C equals D minus 480. Okay, this needs a parenthesis here, just a moment. This is page 7, right parenthesis. Okay, so you need a parenthesis here, my apologies. Let me make that slight fix. I don't know how that thing, oh, okay. And all that plus 380 works out to 1/4 D plus 260. And therefore at 1,500, you plug in 1,500, 1/4 of 1,500 plus 260, and it comes out to $635. Okay, that's that.